This is a nuclear power plant mid-construction.
Usually, countries are only able to build one or two at a time. When you look at this massive, sprawling site, it is not hard to see why. The plant we are looking at here is being built in China. So is this one, and this one, and this one.
Oh, here is another one, and another.
China is by far the fastest growing builder of nuclear power infrastructure. And it is on course to become the biggest, overtaking the United States. The big, screaming question is, how?
If you have been following our channel over the past few years, you will know these names.
Vogtle 3 and 4, Flamanville 3, Hinkley Point C.
We have singled out these plants because they have all ended up heavily delayed.
They are incredibly expensive, or a lot more complicated than originally planned. And you might think that if 3 of the world's big nuclear powers are struggling, it is a problem everywhere.
Well, not so. Atomic energy generation hit a new global record in 2024. Several countries have played a part in making that happen. Like Japan, which has been restarting its reactors after Fukushima.
While India and South Korea have been busily building new ones. Korea's Shinhanul-1 nuclear reactor has been turned on some 12 years after its construction began. India decisively advances into the second stage of its 3-stage nuclear power program.
Tokyo wants to turn one reactor back on and use that power to meet booming demand.
But it is China that has easily made the biggest impact on the nuclear landscape.
Right now, it is second in the list of countries with the most nuclear reactors. But when you look at the number of reactors currently under construction, it is China that is roaring ahead. Tokyo wants to turn one reactor back on and use that power to meet booming demand.
But it is China that has easily made the biggest impact on the nuclear landscape.
Because America currently is not building any.
China is putting its plants together at a much lower cost than other countries.
According to new research from a group of U.S. universities, China is able to build new plants at a cost of around $2 per watt.
That is about half of what France typically pays, while in the United States, it can be a staggering $15 per watt.
Now, if you are wondering why we have picked that unit of measurement, it is because it is what the industry itself uses.
Still, all this talk of numbers, watts, and units of measurement is taking me back to my old school days.
And there is a lot of good memories there, but also a fair few of me being stuck on a question. One solution is personal tutoring, but that tends to be off the table for most people because of the hefty costs.
Which is why I am genuinely so pleased to share Brilliant's new tutor, Koji.
Which can give kids the tailored support they need to thrive.
When your kids get stuck on a problem, Koji helps them find a solution for themselves, instead of just handing over the answer.
It will give hints, suggestions, and reminders, but they are still doing all the thinking.
Say they are midway through brilliance thinking in code course, for example, and unsure what to do next. Instead of getting frustrated or confused, Koji is there to help guide them through each stage.
So if you have kids in grades 5 to 12, or even a college, you have got to give Koji a go.
It will give hints, suggestions, and reminders, but they are still doing all the thinking.
You can click the link below or scan the QR code on screen to begin your Koji journey for free.
You can also upgrade to Premium to unlock all courses.
And right now, the B1M viewers get up to 20% off an annual subscription over at brilliant.org/theb1m. Now, let's get back to those nuclear reactors and find out how China is building so many of them.
Now, there are several reasons for China's big nuclear push.
It uses more electricity than any other country. In fact, it is not even close.
And that demand continues to rise.
Not only does it manufacture basically everything as it has done for decades,
but China is now having to power a new data center boom, electric vehicles, a growing high-speed rail network.
India decisively advances into the second stage of its three-stage nuclear power program.
Nuclear power is a way to generate huge amounts of energy without CO2 emissions, while ensuring the energy is always available, unlike with renewables.
Now, when we think about solar and wind, many regions can generate substantial amounts of energy. The fundamental challenge, however, is that these sources remain intermittent. And right now, in terms of production capacity, we are still operating at only a single-digit percentage of what would ultimately be required to meet the full scale of demand. And a significant share of that production still comes from coal. But coal presents another major challenge because policymakers are
which explains why China is under pressure to get its fossil fuel addiction under control.
But Howard believes it is not the main cause of Beijing's nuclear push.
It is not about just sustainability or just getting rid of, carbon per se. I do not think this is necessarily the highest strategic priority for policymakers. From a long-term perspective, the more
And with the current war going in the Middle East, for sure, the energy independence becomes even more important.
As for how China is managing to construct so many new reactors, and do it so quickly and cheaply.
Well, it is a combination of factors.
Firstly, the political system in China allows it to make a big decision, like whether or not to build a load of new nuclear power plants,
with little to no pushback. And yes, I could be talking about virtually any type of infrastructure here. The story is the same with roads, railways, other energy projects, you name it. Nuclear power is a way to generate huge amounts of energy without CO2 emissions. And the chances are, those plans are going to come to fruition. Whereas in other countries, in democracies, there is always a chance that a new government could get elected. And put pressure on a project, there might be a shift in public opinion, all sorts can happen.
Ultimately, it depends on whether governments are willing to direct significant resources towards specific strategic sectors and recognize them as matters of national importance. So there are three important factors: affordable access to capital, a stable and consistent industrial policy, and the ability.
Which brings us on to one major development here that is specific to nuclear, and it is called Hualong 1. That is the name of China's very own next-generation reactor technology. The reactor, of course, being the place where the nuclear fission actually takes place. This causes heat to be generated, which in turn is used to turn turbines. That is how the electricity is produced.
Previously, China had little choice but to use either new reactors imported from abroad or its own models.
But now, China considers Hualong 1 on a par with what the best of the West can offer. It claims that a single reactor can generate almost 10 billion kilowatt-hours of electricity each year.
Apparently, that is enough to power the lives of around 1 million people in an average developed country.
Despite debuting only a few years ago, there are now over 40 Hualong 1 reactors operating or under construction.
It means China no longer needs to import many parts from abroad to build its new plants. And it can build those plants in an incredibly standardized way.
To scale successfully, you need repeatable processes, clear and consistent guidelines, and an approval system capable of moving with exceptional speed. It is this combination of factors that allows a local industrial cluster to evolve beyond simply importing external technologies. Ultimately, the goal is to build a strong domestic industrial cluster where companies, suppliers, talent, infrastructure, and
which explains why so many of these construction sites look very similar, despite being situated thousands of miles apart in some cases. In fact, let's stop for a minute and have a closer look at a couple of the examples, starting with this one.
Although not a new plant, Fuking was the first to bring one of these new reactors online back in 2021.
Construction began in 2015 with the pouring of the first concrete for the reactor containment building.
2 years later, the structure was topped with a large steel dome made up of 153 prefabricated parts.
Weighing over 300 tons and with a diameter of nearly 47 meters.
Its job is to protect the reactor underneath, as well as stop any radioactive material from escaping.
In 2020, saw the loading of fuel and connection to the grid, with commercial operation achieved the following January.
So it took about 5.5 years from the initial concrete pour to completion.
China says this is a record for the first implementation of a third-generation reactor. Now for comparison, the first new reactor over at Plant Vogtle in the US took 10 years.
Another facility that is worthy of mention is this one, the Jiangsu Nuclear Power Plant. It is said to be the largest site to feature only Hualong 1 reactors.
It already has 2 in operation, with another pair under construction, and 2 more planned after that.
When all 6 are complete, it will mean that 60 billion kilowatt-hours each year of clean energy will have been added to the grid.
They might be building them super fast, but it doesn't mean these Chinese plants are of inferior quality or safety.
Yes, China has its own way of doing things, but just like everyone else, its methods are aligned with the IAEA. That stands for the International Atomic Energy Agency, which has been reviewing China's regulations to make sure they meet global standards.
Pakistan and China signed a $4.8 billion deal to build a nuclear power plant in the country.
Well, not so.
Pakistan is its only customer so far, but there is talk of other nations like Argentina following suit.
More than a dozen nations are in a race to develop small modular reactors, or SMRs for short.
Now, funnily enough, these are reactors that are smaller than traditional ones and come in modular form. That is a good thing, because it means they can be built and deployed more easily. And guess what? China has made the biggest breakthrough with them so far.
2026 is when Linglong 1, which China is calling the world's first fully commercial land-based SMR, is set to come online.
Other SMRs do already exist, but they are either situated on a boat or built mainly for demonstration purposes. Nuclear fusion is yet another area of tech in which China is a frontrunner. And yet, it is China that has recently accomplished a key milestone that probably won't mean anything to you at first when you first hear it.
But I am going to try and explain this to you.
It managed to keep a steady-state long-pulse plasma operation going for 1,337 seconds, which is about 20 minutes.
What ultimately matters is what happens after the system has stabilized. Can the organization scale it reliably and at the... For fusion energy, much of the technology still remains at an experimental and developmental stage. With small modular reactors, the key question... And that brings us to the next frontier of technology. Quantum computing is a good example. The field is still evolving, and it is far too early to know.